So in this series of lessons, we've been learning to name organic chemical compounds. The names of organic chemicals are decided upon by an international group called the International Union of Pure and Applied Chemistry. And they decide on all the rules so that all chemists know what all other chemists are talking about. It's kind of an international language. We've been taking a few liberties with some of those rules just to make it a little bit simpler for high school students. And this is the third lesson in this series. We've covered all of the naming for side chains that have carbon-to-carbon single bonds. We've covered the functional groups with the double bonds. Those have an -ine suffix. We've covered the functional groups that are triple bonds and have an -ine suffix. We've covered the benzene ring side chains, and we call those phenols in this class. We could be a benzene, but we call them just phenols in this class. We've covered all of the halo groups. Those of you who are gamers, these are halo groups. Okay, those are the chloro, fluoro, bromo, iodo side groups. Okay, we've covered the alcohol side groups. Okay, the functional groups that are alcohols. We said that prior to the alcohols, in terms of numbering, all of these functional groups have the same importance. Once we get to the alcohols, not only is the whether they come first, second, or third last important in terms of naming, but so after we get to the alcohols and beyond, those also have an importance in terms of numbering. So if we have any of these functional groups on there and an alcohol group, then we number to get the lowest numbers to this functional group because it's the most important. Okay, and so that continues on for the ketones and the aldehydes. Okay, we have the suffix for "on" for ketones and the suffix "al" for aldehydes. And again, these are if we got any of these functional groups before this ketone, you're going to number from the carbon that gives you the lowest numbers to that double bonded oxygen, the ketone. So you get that's because that's the most important functional group. So now we're starting on the back side. We're getting to the carboxylic acids, the organic acids. Okay. Now, there are a lot of ways to write some of these things, and we've looked at some of these things when we were looking previously at polymerization. Typically, you'll see a general formula for carboxylic acid or organic acid written like this. You can write it out in a complete structural formula. You can condense it. Let's see, I can write it without that dash there. They all mean the same thing. If I needed to put this functional group on the left side of some other organic structure, I might write it like this. Okay? They all mean the same thing. And the suffix for these is oic and the word acid. The suffix for these is oic and the word acid. Okay? So if I just have one carbon, and on that carbon is a double bond to an oxygen, and there's an OH group sitting off the side of it, you need to infer this carbon needs another thing bonded to it, because all carbons need 4 bonds. So that would mean I have a hydrogen attached. Okay? Now, in the IUPAC system, the naming system from the International Union of International Union of Pure and Applied Chemistry, this is called methanoic acid because there's just one carbon, meth. There's no double bonds or triple bonds or any other functional groups to affect the suffix -ane, so it's methane, and then you put oic acid on there. A common name for this is formic acid. Okay? And that's the stuff that ants inject in you when they sting you. So I've been told all my life that you can put Clorox on ant bites and it'll make it feel better. Well, that's because the Clorox is a base and it neutralizes the acid. Okay? A lot of things you can put on ant bites to make it sort of neutralize the acid. Huh? Milk is not a base, but it has some components that, let me think now. I don't know how to think about that a little bit. Okay, I think what happens is they actually do something with the carboxylic acid, and it doesn't neutralizes it, but you make it less intense as an acid. Okay. What? Well, soap is a base. It would help. Okay. Taylor, you had a question?
All of the top row, all of the methanoic acid, which ones are which?
All of these right here are ways of representing generally carboxylic acids. Okay? This is the way one way to represent methanoic acid. You could do you could do it like that.
How would you do a skeletal? Could you do a skeletal structure of a one carbon?
Yeah. That's a skeletal structural formula for methanoic acid. You have to infer there's an H on there. If you have an oxygen, oxygens have to have two bonds. This one already has two bonds. This one needs a hydrogen to terminate. This carbon needs four bonds. There are three on there. You have to infer there's a hydrogen on there. Okay? So that's methanoic acid. Okay, what would this be called? Two carbons. Ethanoic acid. That's the IUPAC naming system. Okay? But there's a common name for this acid too. This is called acetic acid. Okay? It's called acetic acid.
Does that have anything to do with acetate?
Yes, it does. The question is, does it have anything to do with acetate? Since acetate, the acetate ion we represent typically as CH3 CO2 negative. If I put a hydrogen on there, you get CH3 CO2H, CH3 CO2H. Okay? So acetic acid is named as if it's a non-organic acid. Okay? You simply take the polyatomic ion name, which has an 8 ending, and put an ic ending on it. Okay? To name it like an acid. Remember? If it has an 8 ending, it changed to ic with no hydro on the front, if it's a polyatomic ion. So that would be naming as if it's a non-organic acid, when in fact it's really more of an organic acid. Okay? So the system that IUPAC is set up, we'd name this like, in that system, you would name this as if it was ethanoic acid. Okay? All right, let's try this one then. Name this acid.
The branch that goes out to OH, that doesn't have a carbon at the end of the thing.
There's no carbon up here. There's a carbon right here at the corner.
Okay.
And that would be carbon number 1, not that we have to number it, because it has to be on number 1 in this case. Okay? You would only put a number on there as if you had a more important functional group that would cause you to number from something other than this carbon. If it has to be carbon number 1, you don't need to put a 1 next to it. Okay? So this would be called pentanoic acid. Okay?
What would you call, what is that the branch called again? The OH and the O? I just studied that.
Well, if we're just naming what this functional group by itself is, that's a carbonyl or carbonyl.
Right. But what
And
about like all this together?
all together,
Yeah, that.
it's a carboxyl group. Very often you'll hear it called a carboxylic acid group.
Okay.
But the name of the functional group where you have a carbonyl next to this, what would otherwise be called an alcohol group, is a carboxyl group. Okay? Okay, name this compound. Name this chemical, please. There's 1, 2, 3, 4, 5, 6, 7, 8 carbons in the main chain. That's oct. Okay. For prefixes, we've got a phenyl group and 2 chloro groups. Chloro comes before phenyl alphabetically. So phenyl is the one that's going to be closest to the oct. And then chloro is going to come before that because just alphabetically C comes before P. Okay, and you do it that way even if we didn't have 2 of them. You basically ignore the prefix in terms of putting in here alphabetically. Okay, so there's 2 chloros, and you're going to number from. This is the most important functional group here. Here's your carboxylic acid group or your carboxyl group over here. This is 1, 2, 3, so phenyl is on 3. Chloro is on 4 and 6. Chloro is on 4 and 6. 1, 2, 3, 4, 5, 6. Then for suffixes, you've got to name both the acid and the double bond. The acid is more important, it comes last. Double bond comes before that, so this is an oct. And this is on 1, 2, 3, 4, 5, 6. You first get to that double bond on carbon 6, so it's 6-ene, that's the suffix for double bond, and then oic acid.
Why don't you put oic acid on the oct?
You have to have the double bond in there somewhere.
Yeah, no, I'm saying why don't you make it like oxalic acid and then 6 and then, because on the other ones we did pentanoic.
You know how to write a letter?
What?
You know how to write a letter?
Yeah.
Okay, write a letter to the International Union of Pure and Applied Chemistry. They'll be glad to answer. I'm sure they'll be glad to answer that question for you.
That was so mean.
I know, it was mean. I'm sorry. I apologize. I was so mean. Huh?
Why did you read it from right to left when you said earlier in the week that you're supposed to read it from left to right because it would be closer to that side?
Well, we numbered it from over here. I just like to put my carboxylic acids on this side. There's nothing wrong with putting the carboxylic acids on this side.
I know, but that's not what you told me. You said do it to the side that it's closer to me. So, that's not it.
Well,
But that's not what I put because that's not what you told me.
okay, I think maybe you crossed up something of what I was explaining. Maybe I was specific to a particular chemical there in that particular, I don't know. All right, because I don't recall specifically the one you're talking about. You always, so what are you saying? You wrote the names just starting from the left and just going to the right?
Yeah.
Okay. You write the names that are prefixes alphabetically. Okay? Then the suffixes are written according to importance. Least important to most important. Does that make sense?
How do you know what's more important?
Well, on the sheet that I gave you, least important is at the top, most important is down at the bottom. Okay? What? Yes. All right, here's one for you guys to do. Here's a name for you to write a formula for. Yes, write a structural formula for this. Now, you know, we're taking some liberties from the IUPAC system just to keep things more consistent for you guys. I think in reality you're not supposed to have that dash between ene and oic, but that's okay. Just, you know, we're going to try to keep things as simple as possible and still get through the functional group names. That's one way. This is one way to write the answer. This would be carbon number 1. That's where the oic acid is. The carboxyl group goes. You've got 7 carbons, 1, 2, 3, 4, 5, 6, 7. Bromos are on 3, 5, and 7. The double bonds, 2, 5, diene. Ene is a double bond. So it's on 2. So 1, 2, there's a double bond. 3, 4, and 5, there's a double bond. Okay? You could also write it, write your carboxylic acid as CO2H if you wanted to. That's a perfectly acceptable way to write it. Yes?
So you could have put the OH on the other side, right? Yep.
Sure, let me show you that too. So if this is carbon number 1, 2, 3, 4, 5, 6, 7, and we're going to have a double bond between 2 and 3. 1, 2, there's a double bond. 3, 4, 5, there's a double bond. We're going to have bromos on 3, 5, and 7. 1, 2, 3, 4, 5, 6, 7. There's our bromo groups. I have this written differently though.
But you can have the CO2H branching off of the 2R, right? On the other
Yes. So here's if I put it on the left, I could do it like this. 1, 2, 3, 4, 5, 6, 7. Bromines on 3, 1, 2, 3, 5, and 7. Double bonds on 2 and 5. Okay. I could do the carboxylic acid, so looks like that. So 1, 2, 3, 4, 5, 6, 7. Bromines on 3, 5, and 7. Double bonds on 2 and 5. All those are perfectly acceptable representations of this acid.
In the CO2, VOH, whatever, can that branch off of a bromine?
Not off a bromine, no.
He's talking about if you're like on the very end of it, on the other, like say on any of those, the CO2H is just on the other end, or one of the bromines, or like right next to a bromine. All the same carbon. Yeah, that's actually right.
I'm not sure I understand your question. Are you saying could...
So, you take the CO2H and attach it like off of a branch on the bromine, like on the...
All right, with ethers then, please be quiet and listen. With ethers, you have nothing but side chains. Okay? So if this is the ether, and that's what it is, and how many bonds you got to have on an oxygen? 2, thank you. Let's put 2 bonds on there. It's implied there's what right here at the end of the line? A carbon, and each of those carbons have 3 hydrogens. And what do you call that? What's the root name when you have 1 carbon here? Meth. So there's 2 methyl groups on this ether. That's the way we're going to name the ethers in here. Okay, and if it were this kind of ether, that's what you would do. This would be methyl ether, or dimethyl ether.
So how would you number it?
You don't have to. You can only have 2 bonds on an oxygen. They're both going to be side chains on an ether. You don't need to number it. It would be superfluous.
Oh, okay.
Got it?
So that was a carbon.
Yeah.
I'll make
Yeah.
it.
Yeah. Okay. All right, name that. So we've got a 1 carbon chain sticking off this side of the ether. That's methyl. Got a 2 carbon chain sticking off this side of the ether. That's ethyl. And those alkyl side groups like that get named alphabetically. So this is ethyl, methyl, ether. The most important functional group here is this ether. It is an ether because it's an oxygen single bonded to carbons on both sides. Okay? So and it's called an ether. That is its root name, ether. Okay? So you name these as side chains. All right?
Wasn't the one on the left have 3 carbons?
No, this is not a carbon here. This is a bond from a carbon to an oxygen. There's no carbon right there. Got that? Yep.
So, not the prefix, the suffix "ane" was coming into play. What you coming to?
Doesn't even apply here. Name this one. What would you call this one? Huh? Diethyl or ethyl ether? It's not really called bad ether. I just like it. Call it that. All right, give me the structure of this, please. Give me the structure of that. Ten points off. There you go. All right. So octyl propyl ether. 1, 2, 3, 4, 5, 6, 7, 8 carbons on one side. Propyl is meth, eth, prop, or 3 carbons long. There's octyl propyl ether. Okay. All right. Let me throw something at you. A little bit different here. Now, no, I'm not going to ask you to name this one. When you have something that goes around and comes back to itself, we call that a cyclo group. Circle cyclo group, okay? And there are 5 carbons in this chain. We simply call this cyclopentyl ether. That's it. There's an oxygen between 2 carbons. It's ether. Okay? Alrighty. Esters.
What does that say after cyclo?
Pentyl. Esters. You can think of esters as being ethers plus carbonyls, or ethers plus ketones. All right? Ethers plus ketones, although technically it's not a ketone unless there's 2 carbons on both sides. All right? So you've got, but if you think about it as an ether plus a ketone, the ketone side is the parent chain, or the carbonyl side is the parent chain. Okay? The suffix we have for an ester is O8. O8. Alright? So let's see, 1, 2, 3, and then let's put our ether here, and if you think about it that way, you can call this the ketone, and put 1, 2. Okay, now, so this side over here, with the carbonyl, or the ketone if you want to call it that, this is the parent chain. Okay? So the root name is going to be on this, for this part right here. Meth, eth, pro. Okay? Single bonds between the carbons here. So this is a propanoate. And then this side over here where the ether is, that's considered a side chain. Just like this, the carbon chains coming off the ether was a side chain, the side of the ester with the ether, that's a side chain. Meth, eth, prop. So this is propyl. Propyl propanoate. Okay, name this one. Alright, so the root name is going to be the side of this ester where the carbonyl is located. There's 2 carbons in this, so this is an ethanoate. And so this is the side chain. There's no carbon here, there's an oxygen right there. The first carbon is this one, meth, eth, pro, but, 4 carbons, so this is a butyl side chain. Butyl ethanoate. Okay? Now we'll give you a name and let you write a formula. Write a structural formula for hexyl heptanoate. Hexyl heptanoate. Yes, the carbonyl group has to be next to the ether. The chain on the side over here next to the ether is your prefix name. So 1, 2, 3, 4, 5. Oh, I left off a carbon. 1, 2, 3, 4, 5, 6. There's hexyl. Then heptanoate, that's 7 long. So starting with the carbon at the carbonyl, 1, 2, 3, 4, 5, 6, 7. Hexyl heptanoate. Alright, let's go and name amides now. Amides. So the suffix name is amide. The name of the functional group is amide. Okay, they are the same in this case. Amides have a carbonyl next to an amine. So here's our carbon chain. We've got a carbonyl, and that's right next to an amine. Okay. An example might be CH3, CH2, C double bond O, NH2. Okay. If I want to do a structural formula, you can say I'm going to do a skeletal structural formula. 1, 2, 3, 4, 5. So that's a pentyl structural group here. I'm going to put a double bond O and put an N over here. Okay. There's an amide. And since the carbon chain has all single bonds, there's 5 carbons in the chain, that's called, what's this called? This part? 5 carbons, all single bonds. Pentane. Okay, so, and since this is the most important functional group, it has to be on number 1. We don't need to number it. So this is a pentanamide.
So that right there is a structural, or no, skeleton.
Yeah, it's one of the 3 structural formulas. This particular kind of structural formula is called a skeletal structural formula.
And then the other one is, that's the condensed version.
This is a condensed structural formula.
Alright,
And this would be meth-eth-propanamide. Okay?
Amide is a suffix.
Yep, amide is a suffix. Okay? Now, listen carefully. Even though I don't have any hydrogens on this nitrogen, this is a skeletal structural formula. So I most often, don't even write the hydrogens, even on the things like oxygen and nitrogen. How many hydrogens are there on this nitrogen? 2. In addition, how many lone pairs on this nitrogen? 1 lone pair. Okay? 2 electrons, 1 lone pair. This oxygen has 2 bonds to it already. How many hydrogens on this oxygen? None. Oxygens only need 2 bonds. How many lone pairs on that oxygen? 2 lone pairs. Okay? Oxygens have 6 valence electrons. Alright? If I bond twice, that gives it the 8 electrons it needs. The 2 lone pairs are still sitting out here though. You have to know they're there, even though we haven't drawn them there. Okay? Alright, let me give you a structure for you to write a name for. Write a name for this structural formula. Okay? In this structure we have 1, 2, 3, 4, 5, 6 carbons. That's a hex. Okay? We've got a double bond over here. We've got an aldehyde over here. We've got an amide over here, and all those are suffixes. The double bond is least important. This is the number 1 carbon, so this is on 2-ene. The aldehyde is on 6, so that's 6-al. And then it's an amide. And the prefixes are ethyl and chloro. Chloro comes before ethyl. It would be. So this is a dichloro, but whether or not the prefix doesn't have anything to do with where we put it first. Okay, you put them alphabetically by the main functional group name. So, but there's a 4, 4 dichloro, ethyl's on 3 ethyl, hex 2-ene, 6-al amide. Okay? I want to write the formula for this monster here. 7-methyl, 4-propyl, oct, 5-ine, 3-al amide. Sounds like a good name for a Cocker Spaniel or something, doesn't it? What? It's just a joke. It's a dog. Oct is 8 carbons long. 1, 2, 3, 4, 5, 6, 7, 8. Got an amide on the end. I'm going to put it on the right-hand side. So there's our carbonyl, and here's our amine. Let's see then. On number 3 is an alcohol. 1, 2, 3. There's the alcohol group. On number 5 is a triple bond. So 1, 2, 3, 4, 5. Okay. On number 4 is a propyl group. 1, 2, 3, 4. There's meth, eth, prop. And on 7 is a methyl. 1, 2, 3, 4, 5, 6, 7. There's a methyl group right there. Woohoo! All right, I want to go straight to the amines. It's the last one. I know what we got. So here we go. This is the main structure for an amine. All right.